Hello guys, sorry for taking time to do videos. So what I will do in this video, remember that the last thing we did was getting the equation of tangents and all that, right? And I showed you the different ways in which they can ask those questions. So what I want to quickly do in this video is to show you how to sketch the cubic functions, and then on obviously if I add another thing, the video will be too long. So what I'm thinking is that we do this one, and then later on, before I sleep, I'll do another one on the application of calculus, and then we'll be done with calculus. And then maybe we can go to financial math or something, so that we finish, and because really November is around the corner. But I'm thinking, since we'll be given, I don't know if universities are included, but if they are included, if we will be given the holiday as from Wednesday for 14 days, I think that will give me time. Also, I'll try to balance, although I'll be studying, but I'll try to balance as I promised you. So when you're sketching the what you call the cubic functions, you need few things, right? You need really few things. But before we can even get there, what I want you to understand is the increasing and decreasing functions and the stationary points, right? So if something is going that way, if we have something like this going that way, it's increasing, right? When it gets here, it's stationary, right? If we were to get the tangent of the derivative of this graph there, the tangent would be 0. I repeat, if we were to get the derivative, remember that the derivative of a function, that is the gradient of that function. So if we were to find the gradient of this function at the stationary point, the derivative, sorry, would be 0. Why does, remember we said the derivative is gradient. Why is the derivative 0? Because we know that the horizontal line has 0 gradient, the vertical line has an undefined gradient, right? So that is why, and then from here, what it will do, it will be decreasing, right? So I hope that really makes sense. So if this was the case, if it was looking like that, and again, I'll come back to this, what I'm explaining here is actually what we call the concavity, right? And why are we saying it's increasing here? Because if we were to find the tangent of this line, it would be that side. It would only touch this point. You can't find the tangent inside here, right? Because really, if the line was to continue to even touch the graph here, so we are saying that it is increasing because the graph is under the tangent, right? If we were to find another tangent here, it would go like that, right? So it's increasing because the graph is under the tangent. When it gets there, we call that the SP, or the stationary point. It is the local maximum or minimum, right? In this case, it will be the maximum because the graph is going down. So it is the maximum point, right? From there, the graph is what? It's decreasing. It means that from there, the graph is increasing up until it gets there, and then from there, it's decreasing. If we were to take this one is the one that is increasing, and this one is the one that is decreasing. I hope that makes sense, right? So we say this one is concave down, and we say that that one is concave up, right? Concave down, concave up, because it's facing upwards, right? I really hope that makes sense. So it's really, really important for us to be able to find these turning points. Now, why am I telling you about the stationary points? Because if you remember correctly, the standard form of the cubic function is y is equal to ax cubed plus bx squared plus cx plus d, where d is your y-intercept, right? Where d is your y-intercept. And then from there, what will happen? From there, we know that A will determine the shape of your graph, right? A is determining the shape. So if A is greater than 0, meaning A is positive, your graph will go like that, right? So it will have a turning point here, it will have another turning point, right? Let me draw it clearly so that you can see it. It will be like that. So it will turn here, it will increase, turn there, decrease, turn here, and then increase eventually. So these 2 points, right? Point 1 and 2, those are what we call the stationary points. You must be able to find those points to see exactly where your graph will turn, right? And then from there, if A is less than 0, and then it is the other way around, right? It will be going like that. It's going down, right? Again, you have your stationary point here and another stationary point up there, right? I really hope that makes sense. If A is positive, it is going up like that. If it is negative, it's going down like that, right? We'll get also to what we call the point of inflection, but okay, let me not go to the point of inflection yet, right? So how do you get these stationary points? I told you that here, if we were to find the tangent would be zero. If we were to find the tangent would be zero, even there, because they are all horizontal lines. It means that always when you find your stationary point, you must make sure that your derivative, your first derivative, is equal to zero. Then you start solving, right? Okay, Tabang, I'm hearing you. You are saying a lot of things. I'm confused and stuff. It's fine. Let me explain by an example, right? So before we can even go to me explaining with an example, it means that for you to draw a cubic function, right? For you to be able to draw a cubic function, you need three important things, right? For you to be able to draw a cubic function, you need three important things. So what are those things that I need, Chava? Number one, as I told you, you need to determine your stationary points. I'll just write SP, right? Your stationary points. How do you determine your stationary points? By ensuring that your derivative is zero, right? That is how you determine your stationary point. Number two, what should you do? You must find the x and y intercept. That's the second thing you must do. Number three, which is the last thing, obviously, is just to sketch, right? So those are the three things, the three steps that you must always follow, right? So I will just give you one example to start with, and then I show you exactly how do you sketch that particular function, right? But before we can even go to sketching, just to show you, before we can even go to sketching, let's assume that they give you a function, right? And then they say the function is f of x is equal to negative x squared plus 4x minus 3, right? They give you, this is your function, right? This is not a cubic function, it's a quadratic, you can see, but I want to show you something. The first question says to you, determine the stationary point, right? Determine the stationary point. Since it is a cubic, since it is a quadratic, it will only have one stationary point. Because a cubic, a quadratic is either like that or like that, right? So it will only have one stationary point, but a cubic has two stationary points, right? So they say find the stationary point. The stationary point here, I said that the stationary point, you must start by what? By finding the derivative of the graph, find the function, the gradient, I mean to say. So you now know how to derive. That will be 2x, you minus 1, it will be 1, right? That will be plus 4. You know that the constant is 0. From here, if you want to stationary point, I said that your gradient must be 0. So you put this as 0, negative 2x plus 4. You take this to the other side, is negative 2x minus 4. You divide by negative 2 on both sides, your x is 2, right? So it means where x is 2, the x value is the stationary point, the x value is 2. How do you find the y value? I always told you that you substitute in the original. You never substitute in the derivative. Never ever. No problem will ask you to substitute in the derivative. That wouldn't make sense. So when you substitute back there, it will be negative. It will be 2 squared. That will be giving you 4. 4 multiplied by 2, that is 8. So it's negative 4 plus 8. That is giving you 4, and then 4 minus 3, that is giving you 1, right? So it means that the coordinates of the stationary point is 2 is to 1, right? Now you know, now you can sketch your graph. This is your turning point, right? Your stationary point is your turning point, right? Now we got that. You saw how do we get that. Now, what I want you to understand, it means now, what we know is that this tells us that the graph is facing down, right? Because it's a negative, right? So it means that your graph is going basically like that. And then what do you have there? You have 2 is to 1 as the turning point, right? And then the next question asks you, is this function increasing or decreasing at the point where x is equal to 4, right? Now they are being specific. Now they are asking if the graph will be increasing or decreasing at this point, right? So how do you approach such questions? With such questions, you must find the derivative at that particular point. If the derivative what am I doing? If the derivative at that particular point is greater than 0, and then the graph is increasing. If the derivative is less than 0, and then the graph is decreasing, right? I hope that makes sense. So now, obviously, we found our derivative erased, but we said that our derivative would be what? It would be negative 2x, as you can see there, plus 4. So we must substitute 4 because they asked when x is 4, is this function increasing or decreasing at that particular point? So what do? We put 4. This will be negative. We put 4 plus 4. So we know that the derivative of at 4, this is negative 8 plus 4. Negative 8 plus 4, that will be giving you negative 4. So since it is less than 0, negative 4 is less than 0. It means that that graph at point x is equals to 4 is decreasing, right? I really hope that makes sense, right? That makes sense. If they said at a point where x is, you can substitute with any point, right? So if it's less than 0, it's decreasing. If it's greater than 0, then it is increasing, right? And then they would go on and ask you another question. Maybe let's say the third question they ask you, they say for which values of x, right, is the graph, let's say, increasing? For which values of x is this graph increasing? So we can see that this graph is increasing from there, and then it stops there because we said from this point coming this way, it's doing what? It's decreasing, and it's increasing here up until there. So they are asking for which values of x is this graph increasing, as long as x is less than 2, because anything that is less than 2 is this side, right? If you were to draw it in a Cartesian plane, but anything less than 2 is this side. So it's increasing for anything that is less than 2. But now we are trying to be professional, and I'm going to show you how I arrived at this x is less than 2, right? So let's do this. Now we are approaching it mathematically, right? We want to show, because sometimes they can say for which values and they give you 4 marks or 3 marks. You just write that, you only get 1 mark. What they're basically saying is that show us, right? If it's now I know I just explained why it has to be less than 2, but we have to prove it mathematically, right? Remember, we said that if it's increasing, your derivative is greater than 0. That this is what the statement is basically telling us. For which values of x is the function increasing? If it's increasing, we said the derivative must be greater than 0. All right, what is the derivative? We found that the derivative is what? Is negative 2x plus 4. We are basically saying now we must solve this, and I told you that x must be less than 2. Already we know that x must be less than 2, but we are just proving it mathematically, because sometimes they can want you to do that, right? So what do? You simply take this to the other side, you'll be left with negative 2x greater than negative 4. Now, there's one thing that you must remember, that when you have inequalities, right, when you have inequalities, when you divide by negative on both sides, the sign changes, right? It changes the direction. So when you divide by negative 2, you'll be having x, and then this side you'll be having 2. But this, instead of facing that way, it will now face that way because we're dividing by negative. But you can see that we arrived at our answer, which is x is less than 2, by just interpreting the graph. This was just to show mathematically, to prove mathematically how we got to that, right? I really hope that makes sense, right? Now let's do it with a cubic function, and we find the stationary points, and then we sketch from there, right? Let's do that. Now let's assume that they give you a function, and that function is f at x is equal to x cubed minus 6x squared plus 9x plus 10. What is the first thing that you have to do, right? They ask you to, let's say, they ask you to sketch this graph. The first thing to do will be to do what? I told you it will be to determine the SP, which is your stationary points. I said your stationary points. How do you determine your stationary points? You determine your stationary points by what? By finding the derivative of the graph. So if we find the derivative of this function, it will be like that, right? This, we multiply that, will be 3x minus 1, it will be squared, minus 2 multiplied by 6, that will be 12, and then x plus 9, the constant is 0, right? So this is your derivative. The derivative, remember, your derivative is your gradient of that function, right? So we said that for you to determine the stationary point, at the stationary point, the gradient is 0. So it means that our derivative here must be 0, right? And then from there, we can solve for x, right? From there, how do we solve for x? We can see that everything here is divisible by 3, right? So you can divide by 3 to make things easier for yourself. So that will be 0, x squared minus 4, x plus 3, right? Everything we divide by 3, right? And then from there, it will be easier to solve this thing, right? So from there, what will happen? You open your brackets because we can see already that we don't have a common factor. Remember the 3 steps of factorizing. You look for a common factor if it's not the difference of 2 squares. If you can't, then you group your terms in that order, right? So we can see that we tried to find a common factor, which was 3. We divided it, didn't do us any good. We don't have a common factor here. So the second thing we must do is to do what? Is to find the difference of 2 squares. So how do you find the difference of 2 squares? You look at the sign of the last term. It's positive. It's telling you the signs are the same. Which signs are the same? The middle one. So we must put negative and negative. If I'm too fast and you are at grade 12, I'm expecting you to know these things, right? But if you don't know them or you don't remember them, you can tell me so that I make a separate video. I'm quickly explaining how these things work, right? So this will be your x and that will be your x. The factors of 3, that when we add them, they will give us for only factors of 3. 3 is what we call a prime factor or a prime number. It is a prime number. It has only 2 factors, which is 1 in itself, right? So either way, whether you put 3 or 1, the signs are the same, so it wouldn't affect anything, right? So as for proving and stuff, we won't do that today, right? So you will say x minus 3 is equal to 0, x minus 1 is equal to 0. You do that, I don't have space, but we can see that we arrive at x being equal to 3 or x being equal to 1. Now that we have our 2 coordinates, which is 3 and 1, what should we do to find the y value? We substitute it back to the equation, right? So you will write that down, but because I don't have space and because of time, I don't want the video to be too long. What I'll simply do, I'll just simply do it with calculating. So we want the y value here, we want the y value here. So let's start with the easiest one being 1. So if we substitute 1, the 1 cube is 1. All right, minus this one will be 6, obviously. So it's 1 minus 6 and then plus 9. 1 minus 6 is negative 5. Negative 5 plus 9, that will give you 4. And then 4 plus 10, that should be giving you 14, right? So that is 14. So it means that the coordinates, it's 1 is to 14, right? And then what is the coordinates for 3? 3 cubed is 27. And then 3 squared is 9. 9 multiplied by 6. That should give you 54, if I'm not mistaken. And then you add 3 to, that is 18 plus 10. So that should give you approximately 10, right? So that should give you approximately 10, right? So the coordinates here will be 3 is to 10, right? The coordinates here will be 3 is to 10. So we have our stationary point. It means that our first stationary point is this one. Our second stationary point is that one, right? Now, what we should just know is that we can see already that A is positive because it's 1. It's an invisible 1. So we can see from that that our graph should be going up like that, right? So we have our stationary points. I'm going to erase, right? But I'm going to keep these coordinates. Remember, it's 3 is to 10, and then the other one is 1 is to 14, right? So I'm going to erase it because we don't need all of this now. But if I'm too fast to pause the video, go back, and then that's the benefits of doing videos, right? So from there, what do? We find our x and y intercept. So when you find your y intercept, you let x be 0, but I told you that y-intercept is always your d, because if we put 0, 0, 0 here, everything will be 0, right? So we'll be left with that one. I won't entertain it, you substitute, but when you put f and your x is 0, f of 0 is equals to 10, right? So it means that the coordinates is 0 is to 10, right? When x is 0, our y is 10. So what do we want now? We want our x-intercept. In our x-intercept, what do? We let our y be 0, right? So our y is 0, it's equal to x cubed minus 6x squared plus 9x plus 10, right? So here you can do that method I told you of finding the factors, right? You can do that method of finding the factors. But what you will have, I won't do it, you will do it after finding the x-intercept. You must find your x-intercept. So your function will be like this. What do you have here? What do you have there? We know that here, this one will be 1 is to 14. And this one here will be what? Will be 1 is to, will be 3 is to 10, right? And then you have to find your x-intercept. We know that it will cut the y-axis where x0 is to 10, right? So x0 is to 10. You draw your cubic, right? I hope that it makes sense from there, right? I really hope that it makes sense from there. Now, while we are still on that one, what you have to understand is what we call the point of inflection. So what is the point of inflection, right? I will give you exercises to do. What is the point of inflection? The point of inflection. So the point of inflection is a point on a curve where the concavity changes. Remember we said we have concave up and we have concave down. So where it changes, right, you see here, from here, we have concave down, and then from here we have concave up. So the point where it changes, we call that the POI, which is a point of inflection, right? So it's where your concavity changes, right? So how do you find the point of inflection? You find the point of inflection by finding the second derivative, meaning that you derive the first graph, the first you give the original function you're given, you derive it first, finding the gradient, what you've been doing by doing the stationary points. The first derivative, you further derive it to find the second derivative. I really hope that makes sense, right? I really hope so that derivative, this is what you have to. If the derivative is the second derivative is going to be 0, that is telling you that the what you call it, this point of x is the one which is your point of inflection. Right? I really hope that makes sense and I'm not confusing you in any way. I really hope it makes sense and I'm not confusing you in any way. So that is what you have to know, good people, right? For a point of inflection, just know that when it is equal to 0, it is the point of inflection. If this, okay, so now what you will discover also is that when the second derivative is greater than 0 at the stationary point, that will be your local minimum, right? So if you have something like this one, right, being your point of interest, when it's going up like this, that means that here your second derivative is greater than 0. Here your second derivative is less than 0, right? So you don't have to stress much about that one, right? You don't have to stress much about that one. I really hope everything makes sense. So I want you to sketch few functions for me and find the point of inflection. So the first one I want you to sketch for me is f of x is equal to, let's say, x minus 2 squared cube. Let's make it cube plus 8, right? That is the first one I want you to sketch for me. The second one I want you to sketch for me is f of x is equal to 6x minus 2x cubed. And the third and the last one I want you to sketch for me is the function of, let's say, x cubed minus x squared minus 5x minus 3, right? sketch those three things, and then in all of them, show me the point of inflection. So what I'll do when you're done, good people, when I'm giving you exercises, please do them. If you had any problems, let me know. And then what we'll do on the last, I'll send the last video. Oh, I won't send. Okay, I still have to teach you how to find, when you're given a function, how to find the equation of that particular function. Okay, I think I should do that in this video. It's going to be long, people. It's really good. Okay, let's. I'm going to divide it. I'm going to give you. I think I'll combine that one with find the application. Yeah, because it will going to be too long and it's going to challenge it. So that's it for this video.